Hey, what's up everybody? I'd like to welcome you to the second episode of our sampler tutorial series. Today we're moving on to the fun stuff, which is setting up our audio engine, loading and playing sounds. And this is what you're going to have by the end of this tutorial. Thanks for joining us today. If you're not familiar with me, my name is Josh from The Audio Programmer, where we help creators and companies to learn, hire, and create within this world of audio software development. If you find this tutorial helpful, please give it a like and subscribe. You can also join our community. More about that on our website, theaudioprogrammer.com. And without further delay, let's get started. So as I mentioned before, I've created a GitHub repository for the code for this plugin that we're creating. And I've actually enhanced this a little bit. So if you go into the repository itself, link is in the video description below, you can click on this branch section here and you'll see that I've created separate branches for each one of the tutorials. Today we're covering loading and playing samples. If I click in here, and then I go into the commit history, then you'll see that I've created a commit for each major section of this tutorial. So you'll see what we're working on today. First, we're going to add the synth object and voices. Then we're going to do basic sample loading. And then we're going to show how to pitch samples up or down. Then we're going to make a function for loading sounds and loading the rest of the samples. So that's what we're covering today. And you can follow along with each one of these and go into each one of these commits. So if I click in here into this first one, then you'll see the code that I've added. Now what I've done is I have created a comment for each one of the major code additions that I've done for that part. And I think that this is helpful to give people a visual way of being able to see what code gets written and the justification of why it's written the way it is. And I hope that that's helpful for you. So I'm looking forward to hearing your feedback on this enhancement that I've been doing. Please leave a comment and let me know what you think. Okay, here we are in our CMake file within our project. And the first thing that I wanted to make sure that we do is that we have BinaryData, which is where we hold our sounds, listed as a target link library in the bottom section of our CMake. So if that's not there, make sure that you add BinaryData as a target link library, and that will allow us to be able to load the sounds. Once you've added a significant piece like this to your CMake file, you want to make sure that you update it by re-invoking CMake. The way that I do this in CLine is I actually erase the build folder here if I want to make sure that I've absolutely resetted everything and that I don't run into configuration difficulties. And now what that's doing is that's re-invoking CMake for us. And if it doesn't do that automatically, then what you can do is go to the CMake tab and just hit the top left one that's just the reload icon there. And now that's going to re-invoke CMake and ensure that our project is up to date. Once CMake has finished with creating the build files, then we can go over to our plugin processor.h. And we want to include the BinaryData header file. The way you do this is with include, make sure you use quotes, and BinaryData.h. So that will enable us to load our sampled sounds that we included in our project a little bit later on in this tutorial. Now I'm going to give you an overview of the helpful JUCE classes that we're going to use to create our sampler today. The first one is called the Synthesiser class. Now you might be saying, why are you using the Synthesiser class for a sampler? And I think that Synthesiser class is actually a little bit of a misleading name. I think a better name for this class would probably be something like MIDI Playback engine. So whether you were creating a sampler or a synthesizer, you would probably want to start with this class, the Synthesiser class. And this is the class that's going to handle all of the MIDI routing and voice management and audio rendering for you. All right, first thing that we're going to do is create a synthesizer object. Now, before I do that, one thing I wanted to go through is that a lot of times you'll see in JUCE projects, even ones that I did in the past, that many times they'll include the entire JUCE library in each one of the header files that they use. And so you'll see a lot of times it'll say include JUCE header.h. Now JUCE header holds basically the entire library. The way that I like to do this, and it makes the load times faster, is I like to include just the library that I'm going to be using for that particular class or the subset of libraries. Now, if you go back to the documentation here, you can see what library it comes from. If you scroll down here, and we can see that this is in the JUCE Audio Basics library. So what I'll do is I'll just include that library rather than the entire JUCE header. So we would go JUCE Audio Basics, JUCE Audio Basics.h. Once we've done that, then we can go down here to the bottom and we can create a JUCE Synthesiser. And I'll just call this MIDI Playback Engine. And now we've created our MIDI Playback Engine. The next thing that we need to do is give our MIDI Playback Engine some voices. And the number of voices that we have determine how many sounds can be played at once. So if we wanted this to be a monophonic sampler, then we would only give it one voice. If we wanted it to have 8 voices, that is 8 samples that we can play at one time, then we would give our MIDI Playback Engine 8 sampler voice objects. To use the SamplerVoice class, once again, we'll need the library that this comes from, which is JUCE Audio Formats. We'll just copy this, go back to our plugin processor header file, and include that library. Now, the way that you want to add voices to your synth, or what I like to call the MIDI Playback Engine, is using this function called add voice, which requires a new synthesizer voice for each one of the voices that we're going to add. So the way we can do this is go back to our project, to our plugin processor.cpp, and we only need to do this once, so that's why we're going to include it here in the constructor. And now I'll create a for loop. Let's give this sampler 8 voices. Now we will use the add voice method, and here we can create a new sampler voice object for each one of the voices that we're going to add. So this 8 voices is just something that I arbitrarily chose as the number of voices that I want the sampler to have. Now, to slightly improve the readability, what I'll do is I'll make this a class member. That way, the reader of this code does not have to pore all the way through this code in order to figure out how many voices this has and why I've given it that many voices. So we'll create a variable. We'll just call this num_voices. And then we'll go to the header, make this a class member. And this is a good habit to get into. You don't really want what's called magic numbers within your code. And what I could do is I could make this a constant num_voices. And that's fine. A slight optimization on this is if we made it a static const expr auto. And that way that hard codes it at compile time so that that number is not going to be changed. We know that this sampler is going to have 8 voices. That's not going to change throughout the lifetime of the sampler. Now we're back in the synthesizer class documentation, and the next method that we need to call is called set current playback sample rate. This is so when our playback engine is trying to play back a sample, it's able to play it back at the correct pitch. And in order to do that, it needs to know what the current sample rate is. So the place where we're going to do this is in prepare to play. So if we scroll down to our prepare to play function, and for anybody who's just starting out with JUCE, prepare to play is the place where you're normally given an update to a sample rate. So let's say that the sample rate of the DAW that you're operating in suddenly changes, then this would call prepare to play. This also gets called when you first create a new sampler or a new instrument. This is commonly used for any type of DSP processes. They need to know about the sample rate and about the buffer size in order to be able to process the audio correctly. So that's where we're going to set the sample rate for our MIDI playback engine. The only other thing we need to do to get this working correctly is go back to our documentation, and we have this other method called render next block. So this is going to listen for any input MIDI messages coming from our MIDI devices and render the audio accordingly. And this is going to happen in our audio callback. So we can get rid of this ignore unused for MIDI messages. Then here we will just call our MIDI playback engine render next block. And we'll look back at our documentation to see the parameters. The first one that we're going to bring in is our audio buffer, which is our output buffer. The MIDI buffer to listen to MIDI messages that would be coming from a MIDI keyboard. The start sample that we're going to start in the buffer to start filling up that buffer. And then the number of samples that we want to fill that buffer with. So the output buffer is just the one that's coming from process block. That's just buffer. The MIDI buffer is the MIDI messages. The start sample is going to be the very beginning of the buffer, which is going to be at index 0. And the number of samples that we want to process is the entire buffer. So it would be buffer get num samples. And now our MIDI playback engine is all set up and it's ready to start receiving MIDI messages, and we only need to give it some samples to play with, and that's going to be our next step. When it comes to loading audio files with JUCE, the place where we always need to start is the Audio Format Manager class. And this is essentially a class, to keep it simple, that allows us to recognize a WAV file as a WAV file or an AIFF file as an AIFF file and load it into RAM at a later point. So we will go back to our project, go to the header file, and create an Audio Format Manager object as a class member. The next thing we need to do is call this function register basic formats, and that gives us a list of handlers for each audio file type that we can load. So we can just do this here at the beginning of our constructor. It's just something we need to do once, and now we will call register basic formats. The next thing that we want to do is be able to take one of our audio files and load that into RAM. One way that we could do this is using JUCE's memory input stream class. If you scroll down a little bit further, you can see that this takes 3 arguments, which is the data that we're trying to load, the size of the data, and then if we're going to keep an internal copy of the data, which we won't worry about, so we'll just set that to false. If you're wondering where we get the name of the audio file to load, I'll show you. If we go back to pluginprocessor.h, and then we go up here to our BinaryData header and just go into that file with cline, this would be Command B. Then you'll see all of the files that are loaded into our BinaryData. Remember that we got this from our CMake list, where we used the JUCE CMake API to load these sounds. So we have those in a folder in our project. And when we invoked CMake, because we had this in our target link library, this being our BinaryData, then what that did was that created this BinaryData header file right here. And then that's why we have these files that are available to us. And that's the way that we can invoke these, just by calling BinaryData and then the name of the file. So going back here to our memory input stream, we want to create a memory input stream, call the data that we're trying to load, the size of the data, and whether we want to keep an internal copy of it. So let's create a local variable. We'll call this input stream, and we'll make this equal to JUCE memory input stream. And then we have the source data, which in this case we will call BinaryData. And then we'll do this C5 wave. And then the next argument is the source data size. And when we created that BinaryData header file, we have this other variable that's the size of the file that we're trying to load. Then once again, we don't want to keep an internal copy of the data, so we can just set this to false. And now we have just figured out a way to load this the C5 wave audio file into our RAM so that we can use it within our sampler. Next, we're going to use this method createReader4 from the audio format manager class to try to take the memory input stream and read it to make sure that it's a valid audio file. So we can go back here to our code and we will say something like audio reader equals format manager create reader 4, and then in here we want to put our input stream. Now there's one problem here, which is that this create reader 4 takes a unique pointer of input stream, not an input stream itself. So what we're going to need to do is we're going to need to change this input stream into a unique pointer. The way that we will do this is by wrapping this using std make unique, and then this is a JUCE memory input stream. And now we should be fine there. And then here we need to put our input stream. But we're going to have a little problem here, which is that if we try to build this, we will get an error, and I will show you why. It says no matching member function call for call create reader 4. The reason for this is because currently when we called make unique here in our plugin processor, what that's done is that has made our audio processor class, which is sampler audio processor, that's made that the owner of this object input stream that we've created. Now what we want to do is we want to transfer ownership to this reader. The way that we do this is by using std move, and this moves the ownership from the audio processor class that we're in to the reader. So let's try to compile that again, and we should be okay. See, now we have successfully compiled. So just to emphasize the point, the reason that we needed to use std move is because we used make unique. Make unique means that there's only allowed to be one owner for this object. In this case, when we created it here, the owner was the class that we're in, sampler audio processor. And then std move just changed the ownership from there to the reader that we've created. Now we need to get this audio file somehow into our MIDI playback engine. The way that we do this is by going to our SamplerSound class. So the SamplerSound is the audio representation of the sample. And to create the SamplerSound, we have a couple parameters here we need to throw in. One is just the name of the sound that we want. That's just a string. The audio format reader, which is what we just created. And then we have this third argument, which is the MIDI notes, which is represented by this BigInteger type. The way this BigInteger object is used is actually quite interesting. So going to the MIDI spec, if you're familiar with MIDI, then you may know or may not know that you have 128 possible notes that you can assign for MIDI keys, right? And those go from 0 to 127, giving you 128 values. The way this BigInteger object is used is that you can use this to switch on or off any of those MIDI notes from 0 to 127. We'll come back a little bit later to show you how this works in practice, but for now let's go to the rest of the parameters we need for SamplerSound. We have the MIDI note for the normal pitch of the note. So in this case, we are talking about the note C5. Normally in MIDI on a lot of keyboards this is represented by MIDI note 60, so we will create We will put 60 in for that. Then we have attack time in seconds. We'll just make it attack right away, so 0.0. The release time we'll set to something like 0.1, so we just want it to stop the sound as soon as we release the MIDI note. Then we have the max sample length in seconds. We'll set that to something like 10 seconds. So let's go ahead and create this sampler sound. So we'll create a local variable. I'll just call this sound, and we'll make this a JUCE SamplerSound. And we'll go through these one by one. So the first thing is the name represented as a string. Since it's note C5, we will just make a string that's called C5. The next thing is the audio format reader. This is going to be a reference to the audio format reader object that we've created here. Now the problem is that this method createReader4 returns a pointer, not a reference. So what we need to do is dereference it using the star, and then we bring in our reader object. The third parameter is this BigInteger called MIDI notes. And what I'll do for now is I'm just going to create a BigInteger object here. I'll just call this MIDI note. And I will just put that in there for now, and I'll show you how to work with this in just a moment. The next parameter is the MIDI note for the original pitch. Now, as I said, for C5, this would normally be MIDI note 60. So I will just create an int. I will call it original MIDI note. And I will set that to 60. Then we'll pop that in to our arguments here. The next argument is attack time in seconds, and then we have release time in seconds, so we'll just set this to 0.0, 0.1, and then max sample length in seconds, I'll just set that to 10 seconds. So there we go. So now we have a sampler sound. Now going back to the MIDI note, what I'm going to do for now is I'm actually going to set this original MIDI note up here above the BigInteger. And then we can call this function called setBit. So we got MIDI note, setBit. And what this will do, this will just turn on MIDI note 60 for us in this array from, as I was mentioning before, from 0 to 127. We can turn on or off individual MIDI notes. And for this one, we're just turning on one key, which is MIDI note 60, and that's it. Okay, and I'm going to show you a little bit more about how this this BigInteger works in just a moment. So now we've created this sampler sound, and what we could do is we can call MIDI playback engine add sound, and then we see that what this does is it takes a pointer to a synthesizer sound. So sampler sound is just inherited from synthesizer sound. So, so what we need to do is we need to call this a pointer. And the way that we're going to do this in this situation is using the keyword new. Now, for some people that may be a little bit savvy on C++, they'll probably say, oh, wow, you're calling new, but you don't have anywhere that you're calling delete. This is one of these quirks with JUCE where when you actually put this sound into add sound, that the MIDI playback engine, the synthesizer class, actually will manage the memory on this sampler sound. So you're all good to go there. You don't have to worry about calling delete. It's one of those quirks that you just have to know about JUCE by reading the source code. Now let's go ahead and see if this compiles. Okay, so this compiled. Now I'm going to just hit MIDI note 60 on my MIDI keyboard and see if this plays. And we have our first sound that's finally loaded. All right, there's one essential bit that we need to do here in order to make this better, which is that we need to make sure that this reader is not null pointer, right? Because we have this method called createReader4, and what that does is it creates a pointer if this succeeds, right? Now, what I want to do is I don't want to do all of these actions if the reader is null pointer. So the way that we could do this is by wrapping this in an if statement. So if all of this, and then take away the semicolon, then we open our bracket, and then in here we close the bracket. So what that does is it ensures that we're safe and that we're not trying to create a sampler sound if the reader is null pointer. Okay, now let's pull out all these other magic numbers from this function call and make these into local variables to make them a little bit more readable. Okay, so this makes this much more readable. And as you can see, what we have here is the code actually semi-documents what's happening. If I just left those numbers in there, people would need to look back into the SamplerSound constructor to figure out what those parameters mean. Now, by pulling these out to local variables, we can see what they mean. This is an attack, this is a release, and this is a sample length. So much more readable for people who are coming after me to read this code. All right, so let's come back to this BigInteger object again. So as I was saying before, what we could do is we could use BigInteger to switch on individual MIDI notes that we want to apply when we press the key to play this particular sample. Now, currently we only have this set to turn on one note, which is MIDI note 60, but we can actually set this for as many notes as we would like. So under the hood, BigInteger is 128 bits, and we're turning those bits on or off individually. Those are representative of the MIDI notes that we want to turn on or off, and that works out because the size of the MIDI notes that we can turn on or off is also 128. So the way that we could do this is we can actually create a set of notes that we want to turn on. The way that we could do this is we could create a vector of ints, and I will just call this MIDI note set. And then let's set this to MIDI notes from 60 to 67. All right, now that we have our MIDI note set, we can use a for loop in order to iterate through the MIDI note set. I'll call this for auto note in MIDI note set. Then in here, we'll just use our set bit. And then here we will just pop in our note. And then this will turn on bits 60 to 67, so we could play all of those on our MIDI keyboard. And then let's see if we can compile this. I can see that I need to make this variable MIDI notes rather than MIDI note, since we're talking about more than one note now. And then we have const int with the type of const char3 for C5. Oops, I think I made an error here. This needs to be a JUCE string. Okay, now let's go ahead and try again. Okay, so now we have our sampler, and let's see if it plays our notes. Okay, so it plays our notes, and as you can see, we had 7 notes from 60 to 67. Actually, that's 8 notes. And you can hear that it actually pitched those notes up. The reason that it did this is because we have the original MIDI note, which is 60, and then what it did was, because we put the original MIDI note as 60, it automatically pitched those up as in increments. Since it knew the original MIDI note, it knew how much to pitch up the sample by. So that's the way that we can pitch up and pitch down the samples, and you're going to see how that works a little bit more in just a few minutes. All right, so we've successfully loaded one sound, but we probably want this to load a number of sounds, any sound that we give it, right? So what we're going to need to do is we're going to need to pull this out into a function. So what I'll do is I'm going to just do a little comment here, and we'll start talking about what sort of parameters we want this function to have in order to make all of this process generic for any audio file that we give it, right? So one of the first things that we'll want is we want to be able to create a name for this sound that we load. So we're going to need a const JUCE string name. Then we're going to want the original MIDI note value, right? So this will be an int. So original MIDI note. And then we're going to want a collection of MIDI notes that we want this sound to apply to. So if we're trying to stretch this across a number of keys, then we want to be able to provide it with a vector where we provide the notes that we want to be turned on for that particular sound. So this is going to be a std vector of type int. And I'll make this a reference, and we will make this MIDI note set. And then we want to be able to load the file itself, right? So we want this. And the type of file that this is a const void pointer of data. And then we want the size of this, which is going to be size t size in bytes. And just to show you where I get that from, the const void pointer data and the size t, that just once again comes from our BinaryData.h. If you command B in there, then you can see that we have this const char star, and we just have that represented as const void data here, right? So this is our function. These are the arguments, and I will just call this, we will call this load sound, right? It'll take these arguments, and then let's just go ahead and create that for now, right? So I'm just going to copy this, go over to the header file. I will put this right here. So this will return a JUCE sampler sound pointer, okay? And then what we'll do is we will make it where it creates the sampler sound, and then we will, from there, we'll load it separately into our sampler. So let's just make this a little bit neater to make this line up nicely. This, I like how, okay, so there is our function call. Once again, this is going to construct a sampler sound for us. And then I can just get rid of this. And then what we'll do is we'll put this above our constructor here. And then what we'll do is we'll take all of this stuff that we created earlier. Okay. We'll take all of it for now. And then we'll just plop that in here. We'll get rid of all the stuff that we've already taken care of from the arguments. So things like the name, the original MIDI note, the MIDI note set, then all of these are okay. We don't necessarily want the user to be able to adjust these, so these are fine. And then what we'll do is we'll take this, we're going to take this add sound, we're going to pull this out. And then what I'll do is, instead of creating a local variable, we can just say return new. And then what we will do is we will give this a try right now. Okay, so let's go down to our constructor after we've allocated the voices. Now we're going to pop in this function call add sound. And then what we'll do is we'll say load sound, which is our function. Okay, so it's going to need a name. Let's just call this C5. The original MIDI note, which we will call 60. Then we need the MIDI note set, and we will just make that one note, which will be 60. Then we need the data, which will be binary data. And then we will use the C5 wave. And then we just need the wave size. So that's C5 wave size. And that's it. Okay, let's try to compile this and see what happens. All right, looks like we've got a couple errors here. So one is use of undeclared identifier format manager, and that's on format manager create reader 4. Okay, so I see what's happened here, which is that this is not class qualified. So we need this here. We need the name of the class before the function call. That's fine. Okay, compile again. Sometimes I like to show these error messages so you can see how I fix those. Non-const L reference to type vector cannot bind to an initializer list temporary. Okay, I think I can fix that by just making this const. So let's do this, make this const. And then let's try this again. All right, so now let's see what happens. So, all right, we have our note playing. Fantastic. So let's go ahead and we will just load up a whole bunch of other samples and get all of those set up using this add sound and load sound, and we'll see what we have after that. All right, so now I've loaded a whole bunch of sounds. So this may look a little bit overwhelming to you, but just take a look and you'll see that it's basically the same thing that we've been doing all this tutorial. We've just been creating vectors of MIDI notes that we want to activate, the original MIDI note pitch, and so on. So let's go ahead and try and compile this and see what happens. Okay, compiles. Let's play our notes. Okay. Almost. We don't quite have what we need here. You can hear that it's playing just the same note over and over again. So if we take a look up here at this load sound method, I can see what's happened here. So we forgot to make this generic, this binary, so it's just playing the C5 wave and one semitone above it. So what we need is we need to put data in here. So data and then size in bytes for the size. Okay, now let's go ahead and compile again. And we should be good. Excellent. So now we have our sample player. This is finally working. All right, we covered quite a bit in that tutorial. This is one of the foundational episodes and probably one of the more important ones in the series, so I hope you stuck around. In the next tutorial, we're going to talk about setting up the parameter system and a basic user interface. Until then, happy coding, and I'll see you next time.